So first thing is that I forgot to make a quiz, so we won't have a quiz this week. We'll just wait till next Tuesday, or we'll wait till Tuesday to do a quiz. Homework 5 was due last night. Homework 6 is due Tuesday the 19th. And we're doing notes for homework 6. The first part is from chapter 5. Thanks for being patient. So it's possible that we've talked about this before, but just be sure that it's in your notes. When you have -1 to an even power, the result is +1. -1 to any odd power is -1. We're going to start with -1 squared. Just expand. -1 multiplied with itself 2 times. -1 cubed. It's an odd power, so it will be -1. First, we're going to expand. Let's look at this negative and this negative. It's +1. Then this -1. Let's do -1 to the 4th. Those two negatives are +1. Those two negatives are +1. So 1 times 1 is 1. +1. Let's skip to -1 to the 9th. Nine is odd, so it's going to be a -1. Then -1 to the 10th. It's +1. -1 to the power of 11. You're back at -1. Let's do -1 to the 35th. It's an odd power, so it's -1. Right. How about -1 to the 82nd? It's an even power, so we're at +1. going to use this in something like an expression that we want to simplify. And it has a power on some negative number. Negative x y squared, and it's all raised to power 5. I'm going to take this as -1 and raise it to a power of 5. Same for x, it gets a power of 5. And y squared is a power of 5. -1 with an odd power is -1. Negative. Okay, x to the bit. Y has a power of 2 times 5. So this would be negative x to the 5th, y to the 10th. When I say simplify, I would think first you want to expand your problem, combine like terms, and then write your answer without negative exponents. So, do -2 x cubed y to the 5th. And this has a power of 4. So it's fine if you want to have -2 with power 4, but I'm going to split it up even further as the -1 4th. 2 to the 4th. X cubed to the 4th. And y to the 5th to the 4th. Okay. -1 has an even power, so it's +1. 2 to the 4th is 16. X to a power of 3 times 4. Y with a power of 5 times 4. So 1 times 16 is 16. Then x to the 12th, y to the 20th. We have -3, 8 to the -2, and it all has power of 5. So kind of when you see instructions that say solve, there's probably an equal sign. When you say simplify, there's no equal sign. You just take this expression and try to make it easier to read and without any negative exponents. So we're going to take the negative, raise it to power 5, 3 to power 5, a to the negative 2 to the 5th. Negative 1 with an odd power is negative 1. 3 to the 5th is 243. And a has the power of negative 2 times 5. So negative 243, a to the negative 10. And probably in instructions, I'll tell you to take care of any negative exponents, but that's the last step. Let's bring this to the denominator. And we'll have negative 243 over a to the 10th. You can have this negative in the numerator or out front or even in the denominator. Just as two negative sign is similar. 243 where it is. Bring the a to the 10th. Maybe I'm going to try to maybe think about how to explain these instructions when all it says is simplify. Like kind of all the things to do for this. So I know if you need to distribute, you would do that first. You kind of expand your problem, which we're going to do here. And then you combine any like terms, reduce any fractions, and take care of negative exponents. I'll try to see if there's any other things to look out for though over the weekend. Okay, we need to take this and distribute to both two terms inside. AB times 1 over B, AB times 1 over A. Write as AB over A. And we've got AB over B. There's a couple ways to look at it. We've already talked about a number over itself is 1. So A over A reduces to 1. Or you can use your exponent rules. This is a to the first. This is a to the first. And A is your base with the power of 1 minus 1. This A just sitting there. And your base b has a power of the 1 from the numerator minus the 1 from the a to the 0 times b plus a times b to the 0. Any number to power 0 is 1. So this is 1 times b plus a times 1. Which is b plus a. Okay, so we simplify. X squared multiplied with x cubed minus 2x plus 1 over x cubed. Just going to copy down the expression. Take x squared and multiply it with a polynomial. You want to distribute that term to all 3 terms, or all of the terms inside the parentheses. X squared times x cubed is base x with a power of 2 plus 3. X squared times negative 2x will be negative 2, and x has a power of 2 plus 1. X squared times 1 over x cubed, your base is x, and the power is 2 minus 3. Okay, x to the 5th. Subtract 2x cubed. Add x to the negative first, or x with the negative 1 power. Okay, last step is just to take care of the negative sign right here. So x to the 5th, subtract 2x cubed, and then add 1 over x. We're going to simplify 3x plus 1 in parentheses. And let's subtract x minus 2. Okay, so what we need to do is distribute the negative sign to the two terms in that second polynomial. And also just drop those parentheses. Then combine like terms. You've got positive 3x, negative x. That adds up to 2x. 3x minus x is 2x. Positive 1 and a positive 2. Oh, let's check this out. Why distribute the negative? That way, it's kind of part of this. I have to figure out how to make steps for simplify, but you kind of want to expand as much as possible. And then that way you can combine like terms. Like these two like terms will go together now, and these two numbers will go together. And that's kind of makes this problem simplified. When it's also us to the question, when it's a plus sign, you do sort of distribute the plus sign. We'll do that next. But plus x would keep that the same in a plus negative 2. We're going to do a similar but different problem after this one. Let's take 3x. And also we're going to do a couple problems like this. Little symbols to watch out for. I remember somewhere I read like a good explanation of what it means to simplify. I can't remember. I don't know if it was from the book or if it was something on Google, but I'll check it out over the weekend. But this time we take the 3x plus 1. And let's say there's just plus x minus 2. I mean, you sort of do like distribute the plus. Plus 1 times x and a plus 1 times negative 2, something like that. So, and you can also think this of this one also positive of 3x plus 1. So this is also a positive of 3x, positive of 1, positive 1 times x is x. 1 times negative 2 is negative 2. Okay, and then you do that part, like you distribute the symbol around the parentheses to kind of expand your problem, and then you can combine like terms. So 3x plus x is 4x. And then the number values together would be negative 1. All right, and I'm going to do one more kind of using these pieces. We take 3x plus 1 and just multiply right across with x minus 2. And this time you would foil. And we are going to foil, but then also we're going to use a rectangle / square. In a sense, it's going to be a square, but you can multiply using a rectangle, which maybe we'll do later. I don't know. It's not going to be in your homework, but it's still something we can go over. Okay, let's just FOIL. 3x plus 1 and x minus 2. FOIL is and when do you FOIL? When you multiply two polynomials together. So it's this like multiplication part. That's especially when it's like 2 terms times 2 terms. That's specifically like for FOILing. I'm also gonna like after this one explain how to use this rectangle. And that's for multiplying any polynomial with any other polynomial. So I think examples will help. But also for the question, we'll write on the side. When you multiply two binomials together, you use FOIL. Also, thanks for the questions. I like knowing what to explain. Bi stands for two terms in your polynomial is a binomial. Okay, just like a little side, like general expression. If you see x plus a times x plus b, I mean, they don't have to match. Let's maybe like have a y right here. Two-term polynomial multiplied with another two-term polynomial. So you have to see multiplication between two binomials, polynomials that have two terms. And then you do the first, outside, inside, last. All right, but after doing one example with FOILing, we're going to move on to this square. F stands for first, the first term from each pair of parentheses. 3x times x is 3x squared. 3x times -2 would be -6x. So first, those are the outsides. The inside is 1 times x, which is x. And the last part is 1 times -2. It's -2. And you want to combine these like terms. 3x squared minus 5x minus 2. Okay, let's say you don't quite know FOIL or you just like this rectangle. What you do is you put one polynomial on the top and multiply with the other polynomial on the side, like this. It's the same example. So I'm going to just take this. We can copy it down. Same problem. And then instead of doing this foil thing, we make a rectangle or a square. This one's going to be square because the first polynomial has the 3x and a positive 1. And x minus 2, or positive x and negative 2. Then you fill in the square with x multiplied with 3x is 3x squared. X times 1 is x. Negative 2 times 3x is negative 6x. Negative 2 times positive 1 is negative 2. And then you have like terms right here, the negative 6x and the positive x. Okay, after filling out the square, what we did was multiply the top with 3x plus 1. With the side, x minus 2. And we got everything inside the square. The 3x squared minus 5x minus 2. Okay. We're going to do some more problems that you could use foil on, but instead we're going to use a square. And then I will try just one problem where we'll need a rectangle. Let's do x minus 1 times x plus 7. Yeah, I think we can make it work. Let's put the square. And we'll put the first polynomial on top, the x and negative 1. And then here's x and a positive 7. And we're going to multiply. X with x is x squared. And negative x. 7x. Negative 7. And you have like terms, these x values, a positive 7x and a negative x will be 6x. All right, but first we're going to just write what we've done. We've taken x minus 1 and multiplied it with x plus 7. And we've gotten what's inside the square. Just x squared. 6x minus 7. Let's try something not too tough. Plus 2. times x squared plus x minus 3. One way to do this is to multiply x with all 3 terms, and then multiply the 2 with all 3 terms, like foiling, but more to it. I'm also going to just try it with a rectangle. So this time, you need the x squared plus x minus 3 multiplied with x plus 2. Yeah, it's fine. I think we'll just kind of make it clear that we're labeling this guy. It's x squared for the first part. Positive x right here. And a negative 3 right here. And then we fill this in with x times x squared, which is x cubed. Let's go here. 2 times x squared is 2x squared. X times x is x squared. And then 2 times x is 2x. X times negative 3 is negative 3x. The negative 3 times positive 2 is negative 6. And we're also going to need to combine like terms. There are x squared values across from each other right here. And x values right there. So we'll put those together. And I'm just going to kind of write it all down as we get the answer. Okay, we took the top part, the x squared plus x minus 3, and we multiplied it with the side, which was x plus 2. We got everything in the square, which is x cubed. And the first pair of like terms, the 2x squared plus x squared would be 3x squared. Negative 3x and a positive 2x would be negative x. And the last part, minus 6. All right, we're going to do here binomial times binomial. But when you see something like, let's go with x plus 7 times x minus 7. So the first terms match, the second terms match, and what's the symbols in between are a plus or a minus sign somewhere. Like this. You take it's a difference of squares. So you square the first term and subtract squaring the second term. So if you can memorize the difference of squares, we don't need to do a rectangle and we don't need to FOIL. We can just jump to that formula. Get x squared minus 49. I would put it kind of maybe right here, that what I did was use difference of squares, but we'll just put it at the end. It's a difference of squares. Okay. Let's do 4x minus 5 times 4x plus 5. So just copying this down. And noticing that it's a difference of squares. So when you can spot a difference of squares with the first term 4x and each second term is 5, and you've got a minus sign and a plus sign, you can jump to the formula. You take the first term, square it, and then subtract the second term squared. So you need to square 4x minus 5 squared. And that comes from the difference of squares. All right, and then 4 gets squared and x gets squared. So this is 16x squared minus 25. All right, we're going to just do 2 more, and then that's the end of the notes for chapter 5, but we need to start chapter 6. We're going to get into 6.1. Okay, so we're going to divide. Oh, 20x to the 4th plus 15x cubed minus 5x squared. By 5x squared. To divide this polynomial by this polynomial, we're going to just first write that out. We're going to put this over that. Okay, then you just take every term from the polynomial, put it over that value in the denominator. This over there, that over that. So break this into 3 pieces. take 20x to the fourth, put it over 5x squared. And then plus 15x cubed over 5x squared. Minus 5x squared over 5x squared. And then simplify every term, which means reduce your fractions. We want one base for your variable with whatever power. So let's do that like step by step. First one. 20 divided by 5 would be 4. And then the base of x has a power of 4 minus 2. Then plus 15 over 5 would be 3. The base x has a power of 3 minus 2. And then we're subtracting a number over itself, which we've talked about before, would be minus 1. This would be 4x squared, add 3x to the first, minus 1. And a number to this first power is the same number. So 4x squared, add 3x. I'm going to do the same kind of problem. Just switch it up a little. We will divide a squared b squared c minus a b squared c cubed by ABC. Okay, first we're just going to write down that we're taking this expression and dividing it by that one. So put a squared b squared c minus a b squared c cubed over ABC. So we'll take the first term, divide by ABC, take the second term, divide by ABC. So we break this into 2 terms and simplify each one. First is a squared b squared c over b c. Subtract a b squared c cubed. It's also over a c. Base a has a power of 2 minus 1. B, its power is also 2 minus a 1 right here. For C, you could write power 1 minus 1, which would be 0. But also, a number over itself is going to reduce to 1. So this is times 1. Subtract. Same idea here. A over A is 1. Multiplied with the base B, which has a power of 2 minus 1. Times C, and that power is 3 minus 1. Right, first part is A to the first times B to the first. Subtract A to the first times C squared. We have number to the first power is the same number. So this is just A times B minus B times C squared. Okay, there are two things we need to talk about from section 6.1. This will help you with the end of your current homework, the last like 4 or 5 problems. Okay, first part is how to find the greatest common factor and how to factor out the greatest common factor. And the greatest common factor, also called GCF. Okay, the greatest common factor, let's say for a polynomial is the largest monomial that divides each term in the polynomial. Greatest common factor for it is the largest monomial that divides each term in the polynomial evenly. So similar but different from greatest common factor. I'm sorry, from the least common multiple. In the least common multiple, we would factor each number and pick the most of each factor. But with greatest common factor, And I'll try to maybe explain this better if I can, but my first part would be finding the greatest common factor. You look at the numbers first and factor all of the number values. For each factor, you need to find numbers that are, let me see, find the least of any, let me see. So I'm trying to think, you factor every number and you have different factors to look at and you choose the least of any factor. That's a number. And then like you multiply those together and multiply with your variable. And for the variable, take the smallest power. It's not a very like fancy way of explaining it, but I think a few examples will help. Okay, so for the variable, just a second. Okay, thank you guys. So for your variables, you want to find like the smallest power. And like multiply all of this together. Okay, let's start with just two terms and finding their greatest common factor. Find the GCF. Of two terms. The first term will be, let's go with 2x squared y. The other expression or term is going to be, let's do 12 x cubed. Here's common factor. Well, so I'm going to just start working on it, but then we're going to erase this first part. So you kind of factor every number that you see. 2 is factored. It's 2. 12 would be 2 times 6. 6 is 2 times 3. So we've checked out our numbers, we've checked out our factors, and then for each term, find the least of any factor. So there's a 2 in this one, and there's 2 2s in this one. We're going to go here with just 1 2. we're going to take 2 and multiply with other factors, but first I want to point out 2 is common to both of the 2 terms. It's in the first term, it's in the second term. So it's a common factor. 3 is a factor, but it's not common to both terms. So we're not going to use 3. There's no 3's over here, so we're not including that part. Let's go over to x. You would choose the smallest power. So between x squared and x cubed, go with x squared. And then for y has a power 1, this has a power 1, and the smallest, is power 1, which is y. So that's the greatest common factor, 2x squared times y. All right, let's try 3 terms. Let's go with 8a cubed b squared. (16a squared b cubed). Put these all next to each other. Okay, so 16a squared b cubed. A cubed b cubed. So the greatest common factor is, we're going to start with the number part. Let's factor 8. So it's 2 times 4. 4 is 2 times 2. And then factor 16. It's 2 times 8, which is 2 times 4, which is 2 times 2. Let's do 4 times 4. I mean, it doesn't matter, really. We're just trying to fully factor this. It's just easier to read. Then factor 20. And write this as 5 times 4. It's 2 times 2. So we're starting with just the number part of the greatest common factor. You check out your factors, and it has to be common to all 3 terms. So there is a 2 here, and a 2 here, and a 2 here. So you pick the least of your 2's. This one has 3 2's, there's 4 2's, there's 2 2's. So you want to use just 2 2's. even though there's a factor of 5 in this term, there aren't any 5s here or here. So 5 is not common to the other terms. So it's not going to be part of the greatest common factor. All right, then we're on to the base A in its smallest power, which would be either a cubed, a squared, or a cubed. So choose a squared. Then look at b squared, b cubed, or b cubed. Choose the smallest power, b squared. Okay, so we've got 4a squared, b squared. All right, we want to actually factor out the greatest common factor. So we need to practice that a few times. Okay, so factoring from 5x cubed plus 15x squared. Okay, so I'm just going to start with the expression. Or maybe we should do some scratch work first. Let's find the greatest common factor. So you look at 5, it's fully factored. 15 would be 3 times 5. So a factor common to both terms is 5. There's a 5 here and a 5 there. So 5 is going to be part of this. And multiplied with, we're not going to use 3 because 3 is not common to both terms. So leave out 3, move on to x. The smallest power on x is 2. So let's factor out 5x squared. And start with your original expression. We want to factor 5x squared out of it. So from the first term, we've taken out 5. From x cubed, take out x squared, which leaves behind. Factoring 5 from 15 leaves 3. Factor out the x squared to the front. So all that's there is 3. Factor out the greatest common factor. Okay, we've got 6x cubed y minus 18x squared y squared. Okay. Add 12xy cubed. This is messy. Add 12xy cubed. Let's find the greatest common factor first. Okay. We need to factor all of the numbers. So I need some more space, unfortunately. Okay. 6 is 2 times 3. 18. You can do 2 times 9, and that's 3 times 3. 12. Let's go with 2 times 6. 6 is 2 times 3. We're checking the very ends of each of these factor trees for common factors. So we've got 3 common to all terms, and then the least you have of 3. There's only one of them right here. There's 2 3s. There's 1 3. So just use one of the factor. Oops. Oh. I didn't think we would run out of time. Okay. Well, let's just find the common factor and call it a day. We'll come back next time and do grouping. Okay. 3 is common. 2 is also common. There's 2 2s, 1 2, 1 2. So just one of those. X. Choose the smallest power, which is this one right here. Just X. And then Y, there's just Y to the first. Y squared, Y cubed. So go with the smallest power. Okay, we're gonna call it right there, but next time we're gonna actually factor out 6xy from this whole polynomial. Please work on your homework over the weekend. And thank you for coming to class. See you.